Okay, number 19. A curve has a slope for every point on the curve. Whoops, excuse me. A curve has a slope, so that means that's the derivative everywhere. So y prime is equal to 2x plus 3. Which of the following is the equation of the curve that passes through the point? So we're going to integrate that and evaluate it at f of 1 is equal to 2. All right, so the integral of 2x plus 3 dx. So that's going to give me an x squared plus a 3x plus a c is equal to y equals. And then I'm going to plug in 2 so I can find out what c is. So that's going to be 1 squared plus 3 times 1 plus c. So that's 2 equals 1 plus 4 plus c. That's 5. Negative 3 is equal to c. So right here, x squared plus 3x minus 3. Alright, what the heck did I screw up? 3 times 1 is 3, not 4. So that's a 2. That's negative 2. Alright, x squared plus 3x minus 2d. Okay, good. Let number 20, let f be the function above. Which of the following statements are true about f? The limit as x approaches 3 exists. You could graph this if you wanted to. They're pretty simple graphs, but to find the limit at 3 to make sure that it exists, basically you just evaluate each of these functions at 3 and show that they equal each other. So when I do 3 plus 2, that is equal to 5. And I do 4 times 3 minus 7, that equals 5. So that limit exists. It's also going to be continuous there. Okay, for the same reason, when I evaluated at those points, we get the same values. Differentiable at 3. And again, I'm just going to find the derivatives at each one of these. And for x plus 2, the derivative of that's 1. For 4x minus 7, the derivative of that is 4. And they're not equal, so it's not differentiable at x equals 3. So it should be D. Next one, second derivative of a function is given by that. The graph of the second derivative is shown above. For what values of x does the graph have a point of inflection? Points of inflection, where it changes signs. So the points of inflection are going to occur at A because it goes from positive to negative, at 0 because it goes from negative to positive. Again, it's got to change directions. And then not at B because it goes from positive to positive. So the points of inflection occur at 0 and A. Alright, the graph of f prime is shown. And the derivative of f is the line. Oh, right. The graph of f prime, the derivative of f is shown. So this is an f prime, and they want you to find if f of 0 is equal to 5, then f of 1. Again, there's a couple of ways you can do this, but I think the easiest way to do this is if we integrate from 0 to 1, right? From 0 to 1 of the derivative of that, that's equivalent to f of b minus f of a. And they want us to find f of 1, so we're going to solve this. So we're going to do f of 0 plus the integral from 0 to 1 of f prime of x dx will equal f of 1. Alright, so f of 0 they told us was 5. And the integral from 0 to 1, well, the integral of this is just the area here. So we're going to find the area of that, which is 1/2, the base, which is 1, because it's a triangle, and the height is 6. So that's 3, so that should be 5 plus 3, which is 8. And that's that. You could actually come up with the equation of that derivative by finding its slope and it passes through a point, and then integrating that, coming up with that equation, and then evaluating it, f of 1. Okay, next one, second fundamental theorem of calculus, I believe this is. Yeah, the derivative of an integral. Okay, where the upper bound is a function of x. So we're just going to plug that in. So we're going to get sine, take out the t, and put in an x squared cubed. And don't forget to take the derivative of the top. So it's 2x sine x to the 6th, which is e. All right, 24. Let the function be defined. Which of the following is the equation of the tangent line of the graph at x equals 1? So f prime of x is equal to 12x squared minus 5. Which of the following is the equation of the tangent line at 1? All right, so I have to do f prime of 1 so I can figure out the slope. So it's 12 minus 5, which is 7. So now it's y. Well, I've got to figure out the y coordinate. Figure that in a second. Is equal to the slope, which was 7, and x minus 1. At 1, I got to plug 1 back in, so I have to do f of 1 to figure out the y coordinate. So that's 4 times 1 minus 5 plus 3. 4 minus 5 plus 3, negative 1. So what is that, 2? No. Plug in negative 1. So that makes that negative, makes that positive. And that's 4. So minus 4. So now I got to simplify that and put it in slope-intercept form. So y minus 4 equals 7x minus 7. Y equals 7x minus 3, which is a. 25. The particle moves along the x-axis. Position function is given. At what time is the particle at rest? So we want to find out when the velocity is equal to 0. Alright, so we're going to do the velocity, which is the derivative of that. So what's that? 6 t squared minus 42t plus 72. Find out when that's equal to 0. So I'll factor out, I think I factor out a 6. T squared minus 7t plus 12. So that's t minus 4 and t minus 3. So t would equal 4 and 3 when it would be at rest, when velocity, so e. Alright, 2 more. Move this up a little bit. Actually, 3 more. Alright, what is the slope of the line tangent to the curve at that point? Implicit differentiation, right? So let's say 6y times y prime minus 4x equals 0. Product rule. Negative 2x times y prime, don't forget prime, and then the derivative of that's minus 2y. Alright, and where do they want it at the point 3 comma 2? Let me just simplify this a little bit. So this is 6y y prime minus, or excuse me, plus 2x y prime equals 4x minus 2y. Just collecting the y primes on one side. Y prime equals 4x minus 2y divided by 6y plus 2x. And I'm going to plug in the point 2 comma 3 into there. So that is going to give me, let's see if I plug in 3, that's going to give me 12 minus 4 over, that's a y, so 12 minus 6. 8 over 18, which is what, 4 over 9? B. Okay. Let the function, they give you a function. They say g of x is equal to the inverse. Okay, so these are the ordered pairs for the inverse. I'm just going to write it in inverse notation. So inverse has the ordered pairs of 2, 1, which means the original function has to have the ordered pairs 1, 2. They want the value of the derivative of the inverse at 2. Well, what I'm going to do is I'm going to just take the derivative of f of x, which is going to be equal to 3x squared plus 1, and evaluate it at 1. So that'll be 3 plus 1, which is 4, and know that its inverse, the derivative at that point of 2, 1, the derivative of that would be the reciprocal of that, which would be 1/4. But also, please make sure that you know the formula for derivative of the inverse. It's 1 divided by f prime of f inverse of x. Outside's the derivative, inside's the inverse. All right, and last but not least, number 28 here. I'm going to need some space for this, so I'm going to clear those out. And I'm just going to move these out of the way so I can do this problem. So let's see, g is a twice differentiable function. The first derivative is greater than 0, so it is increasing. The function's increasing. And the second derivative is greater than 0, so it's concave up. Concave up. So I have some function that's increasing and is concave up. So I'm just going to plot some points here and just kind of, at g of 4 it's 12, at g of 5 it's 18. Of which of the following could be the possible value of g of 6? So g of 6. Well, I know it's got to be greater than 18, so I'm going to get rid of those values. And here's the other thing I know, is I know the slopes of these are increasing, right? So the slopes at these points have to be increasing. So what I'm going to do is I'm going to find the slopes between these points. So I'm going to use g of 4 is equal to 12. I'm going to use g of 5 is equal to 18. I'm going to find their slopes, and those are the y values, these are the x values. So 18 minus 12, 5 minus 4 is equal to 6. So I know the slope has to be greater than 6. So I'm now going to find out g of 6, what value that goes with. And I'm just going to pick the highest value for right now. I know that's the answer, but I'm going to pick the highest value, see what happens. If I do the slope between these two, I get 27 minus 18 over 6 minus 5. And that slope is, what, 9? Which is greater than 6. So let's try 24 just to g of 6. What if it equaled 24 and I did it between these two values? Well, 24 minus 18 over 6 minus 5 is 6, and it's not greater than it, so it has to be E. Okay, that's up to 28. I think the rest left are calculator.